Welcome to this video. I will show you a proof of concept for Gradecode Basic. Quick scope. The objective of this proof of concept are as follows. Add multiple IID support to give the opportunity to the end user to build their suite itself, including Visual Studio Code, backwards compatibility to SingWrite, and optionally support for Genie. Add the function for multiple file workspaces for work in a project or solution, including this function in SingWrite implementation and maintaining compatibility between editors. Get the option to work as the current versions do. Visual Studio Code have versions for Windows, Linux, and Mac, and the extensions can be coded for multiple platforms in the same extension. If this project is useful, I plan to add Linux and Mac support to my Gradecode Basic extension. Integrate and update solution. I think this is a very important one. Every now and then, there is that post with compiling problems, and almost every time, the main issue is the outdated version they have installed. This project intends to provide an effective, automatic, and simple way for update delivery to the end user. Another important part is to add the integration of DevTools in the same environment that allow the programming of the Gradecode Basic project itself. It might help to ease the learning curve and supply a dev environment for new users to contribute to the project. We will be capable of modify source of the compiler, the Visual Studio Code editor, the extensions, and more. Visual Studio Code integrates step-by-step debugging. It can be added to the extensions. I plan to add this capability, integrating an emulator and, if possible, using the Pickit 2 to add in-circuit debugging. This certainly will be a hard time, but everything is possible. IntelliCode can be coded in the extension. So, I dream with Gradecode Basic being context aware and suggesting me the completion of the line of code. Also, which one doesn't want to see the contents of the help file when reading a command in a line of code? I know, all of this sounds too optimistic, but you are going to see most of it working already. Just before we go to my screen, one fact. Visual Studio Code is the most popular IDE according to Stack Overflow, with nothing less than 50% of the market share. Okay, hold on and let's continue to the next part. The IDE launcher mimics the startup wizard of Visual Studio 2020. For me, Visual Studio 2020 is a very professional and well-designed development environment, and in this case, it will serve me to show the several features for this project. This is the startup wizard. Microsoft invested a lot in user interface design, so I will take advantage of that, and I will be using this philosophy of design. When creating a new project, the wizard relies on project templates to select between different types of projects. Okay, let's open a project. Most development environments feature a project or solution panel where multiple files or objects can be accessed. Okay, finally, let's move out to our program. This is a proof of concept. First, it will connect to the server and see if there is an update available. In this case, it's up to date. Maybe later in the video, there's a new update available. Let's view our most used function, create a new project. Here we'll be using templates. We have GCB microcontroller program project, GCB library project, GCB microcontroller single file program. This is the same functionality as the standard Gradecode basic program, just one file, okay? And the last one, oh well, free basic console app project. Don't freak out. I will explain later this last template, okay? Let's see what is inside of a GCB project. First of all, we have a Visual Studio project file, a SingWrite project file, a Gradecode basic file, and a .vs code folder. Both project files hold the configuration of the project for the respective IDE. Let's open the project in SingWrite. It is important to mention that the capabilities of SingWrite wasn't going to compare to those of VS Code. In example, we can see PDF files or Excel files, with the exception only of CVS files as plain text, obviously. Also, there are some idiosyncrasies and strange behaviors that SingWrite has. I will explain more of this in the forum post. Now, I need to explain some things about Visual Studio Code as a full Microsoft product. I first started this project with the original binaries of Visual Studio Code from Microsoft. VS Code is an open source project under the MIT license, but the Microsoft binaries have a proprietary license that prohibit the use of VS Code in another product. And one can use the logo of Visual Studio Code, the name, or the extension gallery. So, one must compile the source code and patch everything, or for those who want the same vanilla experience but want it with an open source license and all things patched and don't want to compile, there's a side project called VS Codium. This project, every new release from Microsoft, compiles the original code from Microsoft and patches the extension gallery to work in the same way as the original. Then uses their own logos and make the releases. I, as an extra effort to this project, forget the VS Codium repo and make our own branding and little customizations and compiled our own editor. So, enter GCB code. As a side note for templates, the IDE launcher was programmed in a way that the templates are on external TPL files, so it can be updated and added new functionalities without the need to recompile the launcher if needed. Also, mention that the launcher parses the command line arguments to the selected IDE. The launcher can work in legacy mode for SingWrite with a simple command to behave as the traditional way GCB operates. Let's move forward. Now, I will try to explain the functionality of working with projects and why I was driving to implement this. I will show you some personal use cases for this. Remember that more advanced things and use cases can be done as VS Code allows for huge amounts of customization. This is a simple project. For the record, it's a controller for some functions of a CNC machine with 3D printing capabilities. In this example, I have to tailor some lookup tables for a thermistor as a temperature sensor. Here, I can show and use data from Excel files that I can open to the side, or I can show the PDF sheet while I was working with the code. In the terminal menu, I have the run task function. Here, I can use the gradecode basic commands, like in this case, open up the help file. Then, let's show the compiler version. Also, in the run menu, we have the options to start debugging or run without debugging. I will press F5. Here you can note that it only shows me the build related commands. An important aspect of projects is that all tasks can be customized and coded per project. Remember that .vs Code folder? Well, inside we have the task.json file. Here we can customize every task or add new ones. These modifications only apply to the current project. More advanced examples will be shown later in the video. VS Code have source control integration with Git functionality. Every one of these examples came from Git repositories. Here, in the source control tab, we can see that we have 11 changes in our source. Let's open it. In this case, we can see that the assembler code has been changed. Let's compare the differences. Also, we can easily stage the changes, enter a message to commit the changes, push, and a lot of more options. It can also handle GitHub out of the box. The integration of source control is very advanced and very well made. Later in the video, we will can see a more advanced behavior. In this example, I will clone a Git repository from a local server to a folder on the desktop using the integrated source control. Let's see a different workflow. This case of use is about a library for a CAN bus controller. In this workflow, I first need to map a lot of registers in the code. So have the ability to easily see the datasheet. It's a great idea. Then I need to start coding and debugging the code, but it's a library. So I can open my test rig GCB file to the side. On the library file, when I edit some code, I save the file and press F5. Then select Push Library to include it there. This will copy the library to the included directory of Gradecode Basic. Then I can test the code. I select the test rig GCB file, press F5 and select Make Hex and Flash. Then debug the code. So rinse and repeat as necessary. The same applies when I need to code example demos. Have in mind that all of the three examples can communicate between them at the same time. So I need to be able to see the canvas IDs between programs to code accordingly. At the same time, I maybe need to see some capture data. Next, let's see another topic. Gradecode Basic Development. Let's open one special project. This is the GCB compiler source code. Adding this capability will ease the learning curve of new contributors by providing a dev environment out of the box and integrated itself in Gradecode Basic. Let's do some I always do when downloading the code. I always add to the first line of code a print command with the corresponding commit of the current source code to help me see when I am using the last build from source or when editing the source. Let's compile. As a side note, this project always compiles the exe in 32-bit mode with the Gradecode basic parameters. Also, this project allows you to compile the gcbasic.bas from any file. So, if you are in preprocessor.bi and compile, you will successfully compile. VS Code has a very powerful PowerShell terminal integration. Let's run our compiled exe from the PowerShell to see if we see our string. Now, let's do it from the normal Windows command line. Let's open up a side terminal and run our exe. Now, what if you modified the code and build the compiler for testing purposes? But you need to go back to the release binary for normal use? Well, just select go back to release. This will restore the original compiler of the current release or update. Note that we are looking at the development capabilities. We will going to see an strange use case, a multi-road project, and a mix of a GCB project and a free basic project. Hold on. This is the project of 31 kHz book patch of the compiler. You can note that our project have two roots. First, the base GCB project containing mostly GCB files and the other root, the source code of the compiler. Both have their own .vs Code folder. This is not a problem for VS Code. It will behave in a very proficient way. In this workflow, I need to test a lot of different GCB files with different frequencies and clock configurations. And at the same time, I need to edit and build the compiler. Then, build the hex and flash to being able to use my test equipment to debug the compiler. Sounds like a mess, and certainly it is if you use different environments. So let's see how VS Code could help us with this. For a short video, I already used the saved workspace that I used back then. This is another capability. VS Code saves your workspace per project basis. Okay, let's quickly explain the workspace. In the left panel, I opened my multiple GCB files with the corresponding assembler for analysis. On the right panel, I have the preprocessor.bi file from the compiler and an internal oscillator MUX diagram for my chip. Note that when I see the task, I have the ones from the GCB project and the ones from the compiler source. I can select my desired GCB file and compile it, and at the same time, I can build the compiler. Finally, in this use case, let's compare two different frequency assemblers. For video time concerns, I will short the amount of information that I have planned for the next topics. Extensions. In our VS Code distribution, currently we are using 3 third-party extensions and the GCB one that I am coding. All extensions are open source. We have Excel Viewer, PDF Viewer, and Pick Assembler Syntax. Every extension can be coded in VS Code. Let's take a quick look at our extension. We reach our final topic, automatic updates. Let's quickly explain the update chain of events. First, we have one manifest file with the actual version installed. Originally, my framework uses the internal version of the assembly, but in this case, I changed it to an external file, as most probably there will not be a compiled assembly of the launcher every new update, because of the nature of Gradecode Basic. Every time the program launches, it tries to download another manifest file of the current update channel, called CBS. This file is only 100 bytes of size, and it has the information of the last update available at the server. It informs the version, the name of the update package in the server, their checksum, name of the update, description, and the name of the main exe. Then the program compares these versions to the installed version. If the version is greater, it will download the package, and it will upload the patch if checksums coincide. Package is a 7-zip compressed file. Let's see the anatomy of an update and try to make one. On the server side, the update per channel consists of two files, a CBS file plus the name of the channel, and the package with the same name declared in the CBS file. Okay, let's make our update. First, let's see what are the contents of our update. We have our updated version number. That will be 101.01. Currently, we are at 99.01. Now, in the includes, we will change one bad library. And we will add just some way to the update to slow it down a little and the process can be seen. Then we will compress the file, add the final checksum, and upload to the server. I can provide a console application for automation of this process. Thank you for watching this video. I appreciate your time. Until next time.